Okay, so we're on the back page, and we are doing the example problem together. So we have this equation for conic section, r equals 6 over 1 minus 2 sine theta. That is a typo. That should be an r in front of the equal sign. If you can just add that in. Do you see that? Where it's green squiggles? There should be an r in front of the equal sign. Yeah. Yeah, just, don't worry about it. Just put in the r. Okay. So remember, your equation is EP over 1 minus E sine theta. So you can now tell the eccentricity from the equation. What's the eccentricity of this conic? Not 6. Remember, the equation is EP over 1 minus E sine theta. It's 2. So your first bullet point, the eccentricity is 2. So you can now see the eccentricity in the formula. So what type of conic is this? It's a what? It's a hyperbola. Yeah, can we write that down? It's a hyperbola. Yeah, just put it right, yep. Because the eccentricity is over 1, we have a hyperbola. Now, your numerator is E times P. And we know that E is 2. So what is P? It has to be 3, because 2 times 3 gives us 6. So the second bullet point is going to say P equals 2. That's how far you are from the pole to the directrix. That's what that P is. That should be 3. P equals 3. Sorry, I misspoke. All right, so now for the third bullet point, it says look at the operator and the trig function. The operator is whether it's a plus or minus sign. And then what's the orientation? So we see 1 minus 2 sine theta. So that minus sign tells you that the directrix is where? Minus sign. What's that? Okay, so let's back up to the sign. What do we know about this? It's vertical. We know we have a vertical ellipse. And then remember, the denominator controls the directrix. So 1 minus 2 sine theta, it's below. Your directrix is below. So the question is, what is the orientation? It's a vertical orientation. Where is the directrix? The directrix is below because of the minus sign. Now, in a hyperbola, the directrix is in between the 2 branches. And so, for a quick sketch, here's our pole. The directrix is somewhere below. And so that, I don't know if I can do that. Could be a sketch of our hyperbola. The hyperbola will also be below. Okay, so here's where it gets really fun. We are going to write an equation for the hyperbola. It's the same one if you flip to the back, 6 over 1 minus 2 sine theta. Okay, so all right, so for what theta value does the hyperbola intersect the transverse axis? The transverse axis is the major axis. Because we have a vertical orientation, because of the word sine, because we have a vertical orientation, if you think of your unit circle, what 2 angles are on the vertical? They are pi over 2 and 3 pi over 2. Those are the 2 thetas that are on the vertical of our unit circle. So if we put these 2 values in to our equation, if I put pi over 2 into this equation, and I put 3 pi over 2 into the equation, for r, we get -6 and we get 2. If I just put pi over 2 in for theta here, the sine value would be 1, right? The sine of pi over 2 is 1, times 2 is 2. 1 minus 2 is -1. 6 divided by -1 is -6. If I put 3 pi over 2 in for theta, the sine of 3 pi over 2 is negative 1. Negative 1 times 2 is negative 2. 1 minus negative 2 is 3. Yep, 6 over 3 is 2. So the other point is 2, 3 pi over 2. If you graph these, remember you go to your angle first. So you go to pi over 2 first, which is up here, but then you go down 6. So that is, if you think of your xy coordinates, you're 6 below the pole. So that's actually at 0, negative 6, right? You're going down 6. And then 3 pi over 2 is going down, and you go 2 in that direction, so you're going to go down 2. So the other center is 2 below the origin. These are our 2 vertices. The center is halfway between them. What point is halfway between those 2 points? 0, negative 4. 0, negative 4 is halfway between those 2 points. And then A is the distance from the center to each vertex. So what's the value of A here? A is 2. Good. So the next point says use our Unit 5 definition of eccentricity to determine focal length. So that's our old definition, which is that E equals C over A. And from the equation, we know that C is 2. Excuse me, that E is 2. The eccentricity is 2. And A, we just figured out, is 2. So then cross multiply to figure out that C is 4. Now that we know A and C, we can figure out B. Because we have a hyperbola, the equation for B will be A squared plus B squared equals C squared. A is 2. 2 squared is 4. C is 4. C squared is 16. So I can subtract 4 from both sides and get that B squared equals 12. So B equals the square root of 12. So now I can write my equation of the hyperbola. Remember, it's centered at 0, negative 4. I write down these key facts. It's centered at 0, negative 4. A is 2. B is radical 12. And it's a horizontal hyperbola. So because it's horizontal, the x comes first, minus, because it's a hyperbola, and it'll be y plus 4 in the numerator. That will give me the center at 0, negative 4. And then in a hyperbola, a always comes first. So my denominator will be a squared over b squared, and it will equal 1. And that's going to be the rectangular equation for the hyperbola in standard form.